As promised in the last video, I said we would talk about complex numbers in this video. So I'm going to introduce complex numbers, and then we're going to talk about how the operations, how you can perform adding, subtracting, multiplying, and dividing complex numbers. So up until this point in your math career, you've only really worked with our pure imaginary, our pure real numbers. Anything that you worked with before, like the square root of 8 or 1 or a negative 100, they were in our pure real numbers. But now we were introduced in yesterday's video to pure imaginary numbers. Pure imaginary numbers are numbers such as 2i or 16i. Okay. So today we're going to talk about complex numbers, and complex numbers have both a real and an imaginary part to them. And we write them like this. We write them like a plus bi, where a is your real part. Okay, this comes from your real number system, and I comes from your pure imaginary system. Okay, and all this space in the middle between our pure real and pure imaginary numbers is filled with complex numbers. All right, so an example of a complex number might be, and I'll write it in blue, 7 plus 2i. It can also be, it might not have a real part, right? Or the real part might be 0 plus 2i. It could also be something like 7 plus 0i. Okay, so our complex numbers consist of both a real and imaginary part. So how do we go about adding and subtracting complex numbers? Well, it's very similar to how we went about adding and subtracting our real numbers with variables. So you just add and subtract like terms by adding and subtracting the numbers in front. All right, so here we have an example where we're taking 5i and we're adding to it. Remember, there's always a number out in front of parentheses. 1 times negative 3 minus I, and we have to distribute that 1. So we end up with 5i minus 3 minus I. So which of these are like terms? Well, our imaginary parts are like terms. So when we simplify this, we add the numbers in front of our imaginary parts, and I put a 1 in front of that I, that negative 1, just like I would with a variable. And since I write my real numbers first, I'm going to write my negative 3 first. That's my real part. And then I'm going to take 5 and subtract 1 to get a positive 4i. And that is my final answer for this example. My next example, I have to distribute this negative 1 that's in front of this parenthesis to both of these terms. So I get 2 minus 8i minus 2 plus I. So which are my like terms? Well, right now I have 2 and minus 2. I have negative 8i and positive 8i. So when I combine these, well, 2 minus 2 is 0. And again, I always have a number in front of my I. There's a 1. Negative 8 plus 1 is negative 7. So I have a negative 7i. All right, so my next example, I have this positive 1 that's out here in front. I have to distribute that to get rid of my parentheses. So I get 3 minus 2i plus 9 plus 6i. And my like terms would be, I have a 3 and a positive 9. I have a negative 2i and a positive 6i. So when I combine them, 3 plus 9 is 12. Minus 2 plus 6 is a plus 4i. Okay, and my last example here, again, I have this positive 1 out in front of these parentheses, so I have to distribute that. So I get 6 minus 8i minus 6 plus 8i, and my like terms are going to be 6 and negative 6, negative 8i and positive 8i. So when I combine my like terms, I get 0 for my real part, because 6 minus 6 is 0, and then negative 8 plus 8 is also 0. So I get 0 plus 0i as my answer. And I want you to notice that I always answer every single one of these questions if it's a complex number with both a real and an imaginary part. Even if one of them is missing, I still write it as 0 or 0i. So now let's go ahead and multiply and divide square roots of negative numbers. So in yesterday's video, I said you always, always, always take that negative out. So in this example, we have 3 times, I'm taking that negative out of that negative 27. And then I'm going to actually do my multiplication. So I get what's 3 times 27, that is 81. Negative 1 times 81. And now I need to factor that 81. So I get the square root of negative 1 times, I know 81 is 9 times 9, and for square roots I'm looking for groups of 2, so I'm going to pull a 9 out. So I get 9 square root of negative 1, and if you can remember, I squared equaled negative 1, which led to I being equal to the square root of negative 1. So I'm going to replace that square root of negative 1 with I, and that's my final answer. How about when we divide? So what I do first is I always take my negative 1 out and I simplify. So I get negative 1 times 108 over the square root of negative 1 times 9. Well, 108 reduces to, let's see, the square root of 1. Let's see, 2 times 54. 54 is 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. This, I get negative 1 times 3 times 3. So here I have a group of 2 and a group of 3 that get to come out. So that is going to be 6. And remember yesterday I broke it down into 2 radicals. And in the denominator I'm going to pull out my 3. So that's going to be 3 square root of negative 1. So now when I continue to simplify, I get 6i over the square root of 3, times the square root of 3 over 3i. Well, my i's are going to reduce, and 6 divided by 3 is 2, so I end up with 2 root 3. All right, so how about if you start with complex numbers and you want to multiply or divide them? Okay, we're going to do a couple of examples here. When you start with a complex number, you're always going to write it in a plus bi form. So the way that you multiply these is very similar to the way that you would multiply, for instance, say 2x times 3x. We multiply the numbers in front to get 6, and then we multiply the x's and we add the exponent by doing that. We're going to do the same thing here. When we multiply our i's, we're going to add the exponents on the i's. All right, so I get to multiply negative 14 and negative 3. So I know that is a positive 42. And then when I multiply I times I get I squared. And above, we had said that I squared is negative 1. So I'm going to replace all of my I squareds with negative 1. So my final answer here is going to be negative 42 for my real part, and I'm missing my imaginary part, so it is 0i. So we're going to do the same thing here, but now I have to distribute this pure imaginary number 5i across both terms. So I multiply the numbers in front. 5 times 4 is 20i. And then I also now multiply the 5 and the negative 6 to get a negative 30. And when I multiply the I times I get I squared. And now this time when I just change I squared to negative 1, I get this. This is going to make up my real part. So what's negative 30 times negative 1? That's a positive 30 and a positive 20i. All right, let's try this one right here. Here we have a binomial times a binomial, so we're going to go ahead and distribute the first. And I also have radicals in this, so I'm going to leave my radicals unmultiplied. And then I'm going to multiply the 7. Oh, wait a second, I can't do that. There's no number in front. So I'm going to take my 5i and multiply it by the radical 7. That's nice and easy. It makes my life easy. So now I'm going to take 5i and multiply it by radical 7 and then multiply the other one. Okay, so I get a positive 5i radical 7. And now when I multiply 5i times negative 5i, I get a negative 25i squared. Sorry, I have to squeeze that in there. Okay, so now when I go ahead and simplify, I am going to get, I have this nice group of 2 here, so I'm going to pull out a 7 and then I have nothing left. Okay, plus 5i radical 7 or minus 5i radical 7 plus 5i radical 7 leaves me with 0. And now I'm going to replace that I squared with a negative 1. So I get 7 plus 25 equals 32, and I have no complex part, so I'm going to add a 0i to my answer. All right, so now we're going to square this binomial. And we know that squaring a binomial means that we write it twice. All right, so when we square this, I'm going to distribute my 2 first, so I get 4 minus 12i, and then I'm going to distribute my negative 6i, so I get minus 12i plus 36, and remember I times I is I squared. So now I'm going to combine like terms. I have minus 12i is a minus 24i, and I'm going to replace that I squared with a negative 1, which gives me 4 minus 24i minus 36. So now I have to combine more like terms. So sometimes you have to look more than once to combine like terms. 4 minus 36 is a negative 32 minus 24i. Final answer. All right, so now when we divide, we multiply by what's called the complex conjugate. So I'm going to write my denominator with a positive 0. And you remember what the conjugate is. The conjugate is just a changing of the sign in between. So now I'm going to distribute the 7 across the 0 and the negative 10i to get 0 minus 70i. And in the denominator, when I multiply by 0, I just get 0 plus 0. And then when I multiply by 10i, I get 0 minus 100i squared. So now when I combine like terms, all my zeros reduce out, and I get negative 100 times, oops, I forgot to write the squared, and I know I squared is negative 1, so I get negative 70i over positive 100, and I know that reduces to negative 7/10i. I don't have a real part, so when I write this, I'm going to write the real part in as 0 minus 7/10i. Make sure you reduce your fractions. This one is going to be 2 minus I over 2 minus I. Okay, so when I distribute this 4, I get 8 minus 4i. And when I distribute the 2 in the denominator, I get 4